This is one of my favorite topics. All right, some of this is going to be a review, guys, because we've already dealt with particle motion when it came to derivatives, and now we're bringing it back, so particle motion with integrals. All right, so position is denoted as s of t or x of t, sometimes y of t if we're talking vertical motion. All right, so guys, anytime that you have a PVA question, this is my recommendation, right? PVA. If they give me position and they ask for velocity, what needs to be done? Derivative, okay? If they give me velocity and they ask me for acceleration, what needs to be done? Derivative, right? So this direction, we're taking derivatives with respect to time, derivative with respect to time. All right, now we're gonna go the other way. What if they give us acceleration and they ask us about velocity? What is required? Integration. Okay, if they give me velocity and they ask about position, what is required? Okay, an integration. All right, and guys, on a free response question, particle motion, and typically there's one there. A lot of times it's a calculator, one of our calculator active problems. What do you think they would give you? Well, like as far as position, velocity, or acceleration. They typically will give you velocity. Why do you think they give you velocity? Because they can ask you something about acceleration to make sure you know how to take derivatives, and they can ask you something about position to make sure you can integrate. Okay, so a lot of times they'll give you that velocity function. All right, so velocity, it is the derivative of position, okay? I like to write this down. It is the rate of change of position. Velocity is the rate of change of position. Velocity describes how fast position is changing. If I say my velocity is 10 meters per second, that means my position is changing 10 meters every second. Okay? All right, velocity is a vector. Velocity tells you magnitude and direction. Okay? So if I tell you my velocity is negative 10 meters per second, does that mean I'm slowing down? No. It only tells me the direction. I'm moving to the left at a speed of 10 meters per second. All right, velocity is a vector, magnitude and direction. Speed is a scalar, okay? Just magnitude. So if we have velocity and we're asked for speed, we got to know to take the absolute value, okay? All right, acceleration. Acceleration is the first derivative of velocity or the second derivative of position, all right? I'm going to write down that acceleration is the rate of change of velocity. So acceleration describes how fast velocity is changing. Now, if I'm dealing with units of meters and seconds, when I talk about acceleration, my preference is to write it as a ratio, meters per second, because it's easier for me to interpret. So if I say my acceleration is 10 meters per second, that means my velocity is increasing 10 meters per second every second. Does that make sense? Typically, my students always just prefer to write seconds squared, and that's fine. Okay? But I like to write it as the ratio so I can see it as the rate of change of velocity. All right, so look at the next one. Average velocity. We just spent some time on average value. Is that right? So average velocity. So if I'm going to use calculus to find average velocity, I can integrate velocity, divide by the width of the interval. Yes? But before we did that, we had this formula. All right, so I have two formulas that both are equal to average velocity. So what's the transitive property? If A is equal to B and B is equal to C, A and B have to be equal? Yes? All right. So if both of these expressions give me average velocity, then they have to be equal. Can anyone talk me through why those expressions are equal? All right, so if I get in my car and I drive 100 miles, and I go do what? I'm trying to give you small numbers so we can work. Okay, if I get in my car and I drive 100 miles, and it takes me exactly 2 hours, can you tell me how fast I drove? My average velocity? 50 miles per hour, right? All you needed to know was change in position, distance traveled, divided by time that elapsed. Yes? All right, so given position, and I ask for average velocity, I don't need calculus, right? It's just change in position over change in time. But given velocity, and they ask me for average velocity, now I'm going to need calculus, okay? So guys, look, this is change in position. So change in position divided by change in time. Yes? Change in position divided by change in time. Let's focus on this piece of the expression. What do I get when I integrate velocity? Okay, graphically, what do we get contextually? Guys, if I get in my car and I drive 20 miles per hour, constant, 20 miles per hour for 2 hours, can you tell me how fast I drove or how far I drove? 40 miles. Did you do calculus to figure that out? No, because it was constant, right? 20 miles per hour for 2 hours. Velocity times time, right? If my rates are constant, I don't need calculus. The reason we have calculus is because rates are not always constant. But look what we're doing, guys. Velocity times time. Velocity times time. Rate times time. So I just have to do it in tiny little chunks and add it all up. So guys, if you integrate velocity, which velocity is the rate of change of position. So if I integrate the rate of change of position, we get change in position. So this piece of the expression right here is change in position. And then what are we doing? Dividing by change in time. So both of these expressions are change in position divided by change in time. Do you see it? So remember, if you integrate velocity, that is the rate of change of position. So if we integrate rate of change of position, we get change in position. All right, so how do I know which one to use? There you go, based off what they give you. Given position, I don't need calculus, okay? Given velocity, I would use the second expression, okay? And likewise with acceleration, if I want average acceleration, okay? Think about units-wise, meters per second, right? Meters per second squared. So it's change in velocity divided by change in time, okay? This expression over here is also equal to our average acceleration. So focus on this right here. What does this part of the expression tell us? Change in velocity, because acceleration is the rate of change of velocity. If I integrate the rate of change of velocity, we get change in velocity. So both of these expressions are the same. I'm taking change in velocity divided by change in time. Over here with an integral, change in velocity divided by change in time. How do I know which one to use? Depending on what they give us. If they give me velocity, I don't need calculus. If they give us acceleration and ask for acceleration, we do our average value formula. So to find average velocity, integrate velocity, divide by the time interval. If I want average acceleration, integrate acceleration, divide by the time interval. All right, do y'all know the difference between displacement and total distance? So if I stand here and I walk 10 steps to the wall and 10 steps back, what was my displacement? Okay, 0, because displacement is final position minus initial position. Yes, in other words, guys, the word displacement means change in position. So here, this is displacement, change in position, okay, divided by change in time. All right, so right there, if I integrate velocity, okay, which is the rate of change of position, we get change in position, which is displacement. All right, what about total distance? So I stand here, walk 10 steps that way, 10 steps back. What's my total distance? 20. Now do we care about direction? No, right? With displacement, direction matters, right? Movement to the right, movement to the left, okay? Some of it subtracts out. Total distance, I don't care. So total distance, we don't care about direction. How do we ignore the direction? What tells us direction of a particle? The sign of velocity, right? If I don't care about direction, we can ignore the direction by taking absolute value. Let me show it to you graphically. If my velocity function, for some reason, looks like this is velocity. Thank you. Pretend those are equal areas. Let's say this is 5 and this is 5. What is the displacement? 0, right? Because I had If this is horizontal motion, we went 5 to the right and then 5 to the left, so we're right back to where we started. So if I want total distance, okay, I can take the absolute value, which makes everything non-negative. So my speed graph would look like this. And then when I accumulate, we just have 5 plus 5. Does that make sense? So please know the difference between those two. Okay? Displacement, I integrate velocity. Total distance, we integrate absolute value velocity, which is just speed. Okay? All right, so these two right here, fundamental theorem of calculus. So if we have, so up here, going back up here, if I integrate velocity from A to B, velocity being the rate of change in position, so if we integrate velocity from A to B, what does that give us? Change in position. So position at B minus position at A. So I have an equation. I can take this equation and solve for position at B by adding, okay, the initial. So the position at time B is initial plus change. Initial position plus the change in position. Now, most of the time the function will be named for you. Yes, S. I know I try to stay away from S's because they sometimes look like 5s. So yes, position. I don't know why S for position. If it's horizontal, sometimes X, vertical, sometimes Y. Okay, so I can also solve this equation for the initial position, okay, by adding the initial to both sides and then subtracting the change. So if I want the initial position at A, I take the final position at B, minus the change that takes place from A to B. So final position minus the change in position. Okay? All right, and I can use this same concept here, guys, to find a final velocity or an initial velocity. Final velocity would be the initial velocity plus the change in velocity. How would I find change in velocity? By integrating the rate of change in velocity, okay, which is acceleration. All right, so guys, calculus justifications. It's really important when it says justify your answer on a free response question that you justify using calculus arguments. All right, so if we have to justify something, a particle moving to the right or moving up, we have to make the claim that velocity is positive. The direction, the sign of velocity tells us direction. So a particle would move left or down anytime our velocity is negative. All right, speeding up, slowing down. Speed increasing or decreasing. And be careful, speed is not the same as velocity. So how do we tell if something is speeding up? Okay, what's they? Velocity and acceleration have the same sign. So remember, velocity is a vector, acceleration is a vector. Okay? They have magnitude and direction. If these two vectors are working together in the same direction, speeding up. Okay? If they have different signs, it means they're working against each other in opposite directions, slowing down. Okay? All right, ready to work a problem? Did you say no? All right, I think we're looking at 2011. Yes, 2011, question 1. Calculator question. A lot of times your PVA question is a calculator question. 6. All right, so your free response question, there's 2 free response sections. Part 1 is a calculator active, 2 questions, 30 minutes. After 30 minutes, they're going to tell you to put your calculator away. Okay? They're not going to take up the questions. Okay? So they'll call time. They'll say, put your calculator on your desk. They don't take up any questions. They hand out the remaining 4 free response questions, and now you have all 6 of them in front of you, and you have an hour to finish. Because a lot of times, there's so many points you can get just from the setup alone. So let's say you forgot how to do some pieces of this, and then later on it clicks, and you're like, oh, I remember how to do that. Go back to 1 and 2, even though you don't have a calculator, set it up. Mm-hmm. Yep. And in fact, the 2017 question number 1, out of 9 points, 7 of them you could have earned without a calculator. If your calculator had died, if it broke, you'd still get 7 out of the 9 points just from setup. Okay, so yes. Did I answer your question? So 6 for your response, 2 of them with a calculator, 4 non-calculator. But after the first 30 minutes, all they do is take your calculator away, not the questions. The free response questions. The whole test. So the whole test is 3 hours and 15 minutes. First section, multiple choice, part A, 30 questions, 60 minutes, no calculator. So an average of 2 minutes per question. Okay, then they take those up, and they make you flip your answer document over to the other side because it's a completely different color. That's why the next one will start at number 76. So the set part B, 15 questions, 45 minutes. So that's an average of 3 minutes per question. But out of those 15 questions, only 6 of them will actually require a calculator. And you can usually tell by the messy answer choices. If you have answer choices that are all decimals, it's pretty clear it's a calculator question. No, you don't. Who said that? You can use a pencil. You can use a pen. Because a lot of times proctors will be like, you can't use a pen, it's math. No, you could use a pencil or a pen. It's preference. Probably for a writing, like an essay, they probably make you pen. Yeah, no. You can use either or for math. And don't waste time erasing something. If you make a mistake and you know it's wrong, just cross it out. We're not allowed to score cross-out work, like even if it's right. Sometimes I see a student and it's like crossed out, and there's like, they would have earned like 2 or 3 points if they didn't cross it out, but I'm not allowed to score it if it's crossed out. So don't cross anything out unless you're immediately ready to replace it with something else. If you feel like it's wrong, but you don't know what to do, just leave it there. You might accidentally get a point or 2. Okay, so here we go. So the first thing you're going to do on a question like this, okay, calculator question, question number 1, particle for 0 to 6, particle moves along the x-axis. So I got this particle just moving back and forth on the x-axis. Particle's position functions not explicitly given, but we do have the velocity, and they were nice. They gave us the acceleration also, even though we could have taken the derivative ourselves, and they also gave us an initial position. Okay, I like to circle that because I know I'm going to need it at some point in this problem. If you work this entire problem and you never use that initial position, you made a mistake somewhere. All right, so the first thing you're going to do, and I know we're almost out of time, is you are going to put those functions in your calculator. Okay? Because on this question, you're going to need those functions multiple times, so we want to get them in our calculator, okay, and only have to punch them in 1 time. So go to a graph page on your calculator, and let's put velocity in F1 and acceleration in F2. How much time do we have? Okay. If you have your own calculator that you're using right now, go ahead and get these functions in your calculator so that you're ready to go tomorrow. Guys, what are we going to do on the very first question, part A? What is required on part A? All right, so guys, is the speed increasing or decreasing at time 5.5? How do I determine if a particle's speeding up or slowing down? I've got to look at the sign of velocity and the sign of acceleration at that instant. So I don't have to do any calculus here, guys. Both of those functions would already be in the calculator. So I evaluate our velocity function in F1 at 5.5. I write down what it is. Okay? I do the same thing for acceleration. And then we compare the signs.